Welcome to a lesson with Dr. Powell. Let's take a look at derivatives of hyperbolic functions and maybe some definitions too. It should be exactly what you expect. We have cosh of x and sinh of x. How do you think we define tanh of x? Well, the same way. It's just sinh over cosh. And similarly for the other ones. For instance, secant would just be 1 over cosh. Cosecant would be 1 over sinh. And cotanh would be 1 over tanh. Okay, so let's think about the derivatives of these things. What if we take, okay, let's take their definition. So cosh of x is equal to cosine of ix. Sinh of x is equal to negative I times sine of ix. So take the derivative of cosine of ix. Now, using the chain rule, out comes the I, and you get negative sine, negative. Notice that the derivative of cosh is sinh. So let's kind of make a little table here. Let's see down here, we're going to have derivative cosh of x is just sinh. Now, what's the derivative of sinh? Let's think about this. Using the chain rule, we have negative I times cosine of ix, and this multiplied together will be just positive 1. So you end up getting cosh. In other words, the derivative of sinh is actually cosh. The periodicity of these derivatives are a lot better than before. It's just the derivative of cosh is sinh, derivative of sinh is cosh, back and forth, no negatives in here at all whatsoever. But now the derivatives of the others are exactly what you should expect, except where what's different, cosh being sent to a positive sinh could make it a little different. Let's derive the different derivatives, or kind of come up with what the formulas should be using this idea of cosine and sine of ix. So let's start with tangent. So we take its derivative, and we do this by thinking of I sine ix over cosine ix, and maybe we'll use the quotient rule. So I end up getting cosine squared ix on the bottom. On the top we have this. So take the derivative of this, and honestly, why don't we just use sinh and cosh? We could do that because we already know their derivatives. So this might actually be simpler just to do that. Okay. Because we only use these definitions right here to establish that fact, but really, why don't we just use this? So we think of tanh as being sinh over cosh, and we can use the quotient rule here. So we have cosh squared on the bottom. On the top, we have the derivative of sinh, which is cosh, but then times cosh, so it's just cosh squared. Then minus sinh times the derivative of cosh, which is sinh, minus sinh. Now, if you recall, this is like x squared minus y squared equals 1 on the unit hyperbola, so this is just 1. And so we end up getting just 1 over cosh squared, which is just secant squared. So as expected, tanh gives us secant. Now, cotanh, let's think about that. How would things change for cotanh? Well, it would be, well, for one, this would be a this would be a sinh down here because because sinh would be in the denominator. And then in the numerator, let's see what we would have. We would have, let's see, let's just think about this. So we have cosh over sinh. So take the derivative of cosh, which is sinh times sinh. So it'd be sinh squared right here. So it'd be sinh squared. And then if we take the top times the derivative of the bottom, which is cosh squared. So notice it'd be the negative of what we had before. Because you just kind of interchange the order and the negatives there. So it's -1. So it's -1 over sinh squared, which is negative cosecant squared x. And that's exactly what we would have expected for cotant. So pretty similar. Okay. Next, so we did cosh, sinh, tant, and cotant. Why don't we do cosecant right now? Okay, cosecant. So cosecant, so this is like 1 over sinh. So we could think of a chain rule effect if you want, thinking of this as 1 over sinh, and think of like sinh to the -1. So the result would be sinh to the -2 with a negative using a power rule. So sinh squared with a -1, but then multiplied by the derivative of sinh, which is simply cosh. And the -1 came from, so we're thinking like u to the -1, like negative u to the -2, and u was sinh. So that's kind of where we got that. Then times the derivative of sinh using the chain rule. I mean, you don't have to do it this way. You could use the quotient rule, but it was just right there. So anyhow, we get this, and this would be, notice you get negative cosh over sinh, which would be cotant. And then you have 1 over sinh, which is cosecant. So it's exactly what you'd expect, actually. Negative cosecant x cotangent x. Notice how it looks the same. I mean, it's the same format. The only difference so far is this one, the cosine to the positive sign. And actually, that same difference is going to be apparent when we do secant. And it comes from the fact that it was so for cosh, different for cosh. So really the only two that'll be different are going to be the normal, are going to be the cosh and the sinh, and the secant, but all the rest of them, the derivative ideas will be the same, or the derivative formulas will be the same. Okay, so secant, let's see what's going to happen with this. So think of it as 1 over cosh, and again, apply a chain rule if you want with a negative, with a u to the -1 if you like. So you can have a cosh squared on the bottom, and because it's in the denominator, and then you'll have a -1 again, but then times the derivative of cosh, which is that right? Yes, the derivative of cosh, which is sinh. Okay. So notice you end up getting sinh over cosh, which is tant, and you end up getting a 1 over cosh, which is secant, but you have a negative in it all. So it's negative secant x tangent x. Notice it looks like secant tangent, but you have a negative on it, where you didn't have a negative on it before when it was just regular secant. So these are the derivative formulas for the hyperbolic trigonometric functions. Thanks for watching.